Alright, the next theorem that we're going to prove is the alternate exterior angle converse theorem. Alternate exterior. So the alternate exterior angle converse theorem is going to be pretty much equivalent to, or the same process as the alternate interior angle converse theorem. Our goal is still to prove that the lines are parallel, but this time we're going to do it using the alternate exterior angles. And so what it says is that if the alternate exterior angles are congruent, then the lines will be parallel. All right, so just like before, we need a diagram here. I'm going to draw two lines that appear to be parallel, but we don't know that. And they will be intersected here by a transversal, P, Q, and T. I'm going to label my angles here, 7 and 8. And so then what I'm trying to prove is that given that my alternate exterior angles are congruent, so I either can pick 1 and 7 or 2 and 8. I'll go with 1 and 7. Then I want to prove that the lines are parallel to each other. All right, perfect. So this is going to roll pretty much exactly the same way that my alternate interior angle theorem or converse theorem went, where I'm trying to get back to my corresponding angles postulate, the converse of that. So if I can show that two of my corresponding angles are congruent, then I'll be good enough here to say that my lines are parallel. So just like before, I'll start with angle 1 is congruent to angle 7, and that's given to me. And so what I'm going to try and do is connect a pair of vertical angles. In this case, let's go with 1 and 3. And what I'll end up being able to do is say that 3 and 7 are congruent. So I will say that angle 1 and angle 3 are vertical angles. How do I know that? Well, it is assumed from the diagram. Next, I will immediately say that angle 1 is congruent to angle 3 using my vertical angle congruence theorem. It says that if two angles are vertical, then they are congruent. I feel like it's a good time to stop and take some appreciation for the vertical angle congruence theorem. We've been using a vertical angle congruence theorem for a long time now, and just think about how many steps it saved us along the way, because our initial proof of the vertical angle congruence theorem was like 5 steps maybe, and each time that I use this now, I'm essentially cutting out 4 of those, so it's been a big help along the way. Which is nice. So angle 1 is congruent to angle 3, which then I can say that angle 3 is congruent to angle 7 by the transitive property. Our favorite property. And that is linking together statements 1 and 3. And so now that I have angles 3 and angle 7 congruent, these are corresponding angles. And what do we know? Well, it's our one postulate that we have that proves that lines are parallel, and that's if the corresponding angle is congruent, then lines are parallel. So I can just jump right to statement number 5, which is that P is parallel to Q. And the reason for that is that if the corresponding angles are congruent, then the lines are parallel. And the lines are parallel. Perfect. Okay, and that links back to 4. So what I've shown here is that just the converse of my alternate exterior angle theorem. The alternate exterior angle theorem told me that if the lines are parallel, then the alternate exterior angles are congruent. So the converse of that, which is not always true, but in this case the converse of my alternate exterior angle theorem is true, says that if the alternate exterior angles are congruent, then lines will be parallel. And so that would always be the case, and now I can use this theorem moving forward.